Welcome to Making the Most of Maths Online. This short video will examine the lessons learnt about the impact of remote learning on primary children and their mathematics. We will suggest a change in approach and offer a few examples to support teachers in making the most of Maths Online. For this video, we've drawn on the documents shown here, documents from the DFE, EEF and Cambridge Mathematics. And we've taken the definition of remote education from What's Working Well in Remote Education, as shown here. So we're thinking about any learning that happens outside the classroom with the teacher not present in the same location as the pupils. And that will include digital, but not always rely on being digital. And it doesn't always have to be live. So here are the main lessons that we learned from the first lockdown and then children who were at home returning to school in September. That the main impact was on mathematical behaviours and mathematical communities. So children who'd been at home during the lockdown were more reluctant to talk about their thinking and to share their ideas when they returned to school in September. They were less mathematical in the way that they behaved, and this in turn had an impact on their use of language in mathematics. We also had some negative impact in some families on the parental-child relationship as a result of remote maths learning. So these are really key, and we obviously want to avoid this with any future remote learning. So we want to consider both why this might have happened and then how we address it in the future. So thinking about why this happened, we thought this pedagogic design spectrum was quite useful, which we've taken from Espresso 30 by Cambridge Mathematics. And thinking about the provision for remote learners in the first lockdown, what we observed was most of it sat within the instructive end of that spectrum. There was a lot of drill and practice, a lot of single response required, predetermined tasks. And that was because that was a lot easier to provide than the manipulable and the constructive. But I think it's quite clear that a very heavy instructive diet for children is likely to result in them talking less about their mathematics, sharing their thinking less, and probably reasoning less, depending on how that's been done. And so that's what we need to think about, is how do we move remote learning and the provision for remote learners from being heavily instructive to including and encompassing manipulable and constructive, which are far more challenging to do. One of the things in the Espresso, it says that mathematics learning apps are generally more instructive as well, and we need learners to have a range of experiences across that spectrum. And this fits with the expectations from the guidance for schools provided by the DFE, that we're thinking about how do we transfer what we already know about effective teaching in the live classroom, how do we transfer that into remote education? And that will include providing opportunities for interactivity, including questioning, eliciting and reflective discussion. So we're thinking about how do we get those? And we want to suggest this change. We're suggesting teachers need to think about increasing opportunities to both reason and share thinking. And we've put some thoughts about what that means in practice. So looking for learners to notice and wonder. Expecting learners to create their own examples. Having small groups supported by the teacher as part of the provision. And supporting mathematical talk, for example, through sentence starters. And where we're thinking about small groups supported by the teacher as part of the provision, we would expect that all pupils have access to that, but that we would be thinking about our disadvantaged pupils having more access. And we're going to think about two approaches that will provide more opportunities to both reason and share thinking. One is about working on rather than working through mathematics, and the other is exploring and sharing more visual representations. And both of these pick up on elements that sit in the literature about what improves the learning experience for children remotely. Working on rather than working through mathematics is something that comes from the work of John Mason. And so rather than just working in that instructive way, coming up with lots of single answers, and that's all you're doing, we're thinking about changing the way you're viewing the mathematics you're looking at so that you're actually thinking mathematically about it to work on it. And we're going to start with that and think about things that might sit within that instructive part of the spectrum if you didn't add a little question in, but a particular question can change it from just being instructive, move where it sits in that spectrum, and it can mean that children are working on rather than working through the mathematics. So let's consider a couple of examples of this. So we're going to have some subtractions, a whole list of subtractions to do. And if it was just the list of subtractions, we would be in that instructive part of the spectrum. But we've got a couple of questions here. What do you notice? And which two do you think are the odd ones out? Why? And then can you draw something to show your thinking? So suddenly this list of subtractions we're about to see has more to it than just finding the answers. You are still going to need to look at them and work them out in order to talk about which ones are the odd ones out and why. But there is a lot more mathematical thinking going on here. So here's the list of subtractions. You might want to pause and look at those for yourself. These have been written, think with a particular bit of mathematics in mind. So these have been written to draw on and connect prior learning, understanding of place value, connecting with subtraction. So they've been very deliberately done. But one of the things about asking the question, what do you notice, is there's lots of things you might notice. It's something that everybody can answer. Everybody can notice something. So it's a good starting point and a way of getting everybody involved in conversation, in dialogue. But then we've got this, which two do you think are the odd ones out? We're now going to have to look more carefully, and it gets us to think about the structure of the numbers and the way that those subtractions are formed. And there may be more than one answer to that, but you're going to need to justify your thinking. So this is where the reasoning is coming in, and this is where the potential for talk is coming in. So that takes that into a small group situation. You won't want to be doing that in a whole class, but you would want to be doing that with a small group. And the drawing something to show your thinking is also connecting the symbolic with the representation, with the images, and there's a nice connection going on there. But there's a further thing we can ask here that really takes that thinking and makes it even deeper. And this is now make up your own list of subtractions with two odd ones out. Now you might choose to do the same reason for the odd ones out as were in this list, or you might choose something different. But this really pushes thinking and understanding and will reveal a lot about that learner's thinking about subtraction. So what we've done here is to take a list of subtractions that could have just been work these out in the instructive end of the spectrum and deliberately formed that list in order to have something to notice. And we've done this around odd ones out and about drawing connections between prior learning, and then ask the learners to make up their own list. So this is what we mean about increasing opportunities to both reason and share thinking. Let's have another look at working on with a different list of calculations. Now we're thinking multiplications, and we've got different questions here. Again, it could have just been working out the multiplications, but actually what we're asking you to do again is to notice, this noticing. But now the question is, what's missing and why? Now this might be a new bit of learning that you're introducing here, and you're using this as a way into it, and then the conversation in the small groups will be eliciting that new bit of learning. So again, you might want to pause and have a go at these yourself and then answer those questions and think what that discussion might be. Again, this is a list of calculations that has been put together with that particular thinking in mind. So what you might have noticed here is that all these calculations involve prime factors. And what the numbers that are missing are prime numbers in the 20s. So these are all the numbers in the 20s with their prime made by their prime factors, but we have the prime numbers missing. And again, make up your own set of multiplications. I might ask you to do it for the numbers 30 to 39, or I might say you choose any decade you like. And what do you notice? So again, we're taking that thinking further, and that provides lots of opportunities for reasoning, for sharing thinking, and also for assessing. So those two examples have been made with calculations that have been purposefully put together to go with those questions. But you could use any list of calculations that you might have in any of your materials that you're using and put a question on it yourself, add a question to them. And here's some of the questions that you might ask. So what do you notice is always a good opener. So we've had what is missing. Which one is the odd one out? We had which two are the odd ones out? Why? But you also might ask which ones use the same facts. Which one is the easiest or hardest and why? Which ones are not correct? Why? And then following that up with make up your own, whatever it is. So we had make up your own example where there are subtractions, where there are two odd ones out. Make up your own where two are not correct. Okay, and that sort of thing. So we've got this whole noticing as a starting point. Then we get a specific question that focuses children to look more closely at the calculations, to go beyond doing the calculations. And then we ask them to make up their own example. And that provides a lot of opportunities for reasoning. And then when you come to your small group work, to share that reasoning, to share that thinking. So this is working on rather than working through. So I want to go back and just pick up on that small group supported by the teacher as part of the provision. We've got these increased opportunities to reason. Now we need to share our thinking and just some of the things for us to think about around that. So there are different ways that you might manage that small group provision and that you also might prepare for it. So you might have open questions where everyone has something to say and everyone can speak. So what do you notice is a good example of that. And a sentence starter to support would be I notice, and we'll have an example of that in a moment. You might get children to write and draw and hold up their work, screenshot, and then use that to share the thinking and get everybody to sort of discuss what they notice. Now, one of the things that's important is that any additional technical demand should sit with the teacher, as in that example. So having some paper to write on, to draw on, and to hold that up, that's all very straightforward for the learners. And for the teacher, you need to know how do you screenshot and then show that to the learners, and we'll have an example of that in a moment. It could be that children are sending you their responses prior to the small group session, and then you can look at those and select and order ready to build the learning in that small group session. Alternatively, you might anticipate the different responses that might come and then prepare some of those, either just to say them verbally, or you might have some written or drawn to ask the children, is that what you did? And then if it is, they then explain their thinking. So they're looking to match their thinking to something that you have anticipated. So we'll look at some examples of those. And we're going to do that through the second of these approaches, which is exploring and sharing more visual representations. And this is something that in the research comes up quite a number of times, that this is something missing often from the remote learning, and it's a key element of understanding mathematics. So we need to think about how we get that in. And one of the ways we do that is to start from some sort of visual representation. And we thought this is an opportunity just to think about this model, what we call the connective model, which we've adapted from Derek Haylock and Anne Coburn, where we're thinking about there are different ways that mathematics is represented. It can be represented in a context, through mathematically structured images, with language and with symbols. And what's important is connecting those up. And that's often where the talk sits. Those opportunities for talk is in connecting up those different elements of the connective model. So starting from a visual representation, which might be contextual or it might be mathematically structured, either of those gives you an opportunity to then connect language and symbols and have that sort of discussion around that. So here's a picture that I've taken and created to have a look at. And just the first thing is, what do you notice? So this would be something that we might do that with the whole class, or we might just do that in groups to start off with. But it's one of those everybody can answer, an open question, everyone can have something to say, and I might put up the sentence starter, I noticed that, and get some responses to it. But what I might send you away to do is to think about what calculations you could write to match what you can see, and how many different calculations could you write. And then you might draw your own picture to show different groups. So we've got a couple of things here that when we come back together in our small group that we might share. We might share the calculations that you've written to match my picture, or I might ask, did anybody write 4 add 4? Where's that in the picture? Where's the 4 add 4 in your picture? So I might have anticipated and get people to explain what I've done, or I might use the calculations they've sent me. But if I've got you all to draw a picture that shows different groups and we want to now share those, this is a hold it up to the camera. So holding it up, take a screenshot, and then we use that. And here's an example that I did with some teachers where they drew their own pictures about groups of things here. It was sort of in a multiplication context. We'd been looking at some pictures where there were groups and writing multiplications, and then they wrote their own pictures. And I took that screenshot. So now what we could do is we could all look at that and we can do some talking about it, finding things that are same, that are different, identifying multiplications. Can we see groups of 3? Where can you see groups of 3? How many groups of 3? In which picture is that? How there's groups of 3 in quite a lot of these pictures, and so on. So it's a very simple way of sharing the children's thinking and then being able to have a discussion about that thinking. A second idea is to have 2 pictures as we've got here and start with a question, what's the same and what's different? So we've got 2 pictures we're comparing, and again that's with the whole class. We might use the sentence starter, I notice. So I'm going to take you through a little sequence here and actually really identify, like I just did with the last one, but just how we might move between whole class, independent and small group, and where that flow of the mathematics is, and the reasoning and the talk. So we do this all together. But then what I might do is give you one of those pictures and to work on independently. And depending on what the picture is and the age of the children, it might be what numbers or what calculations can you write to match this picture. So for the one we just had, it would be what calculations can you write. So take one of those pictures. Then we come back into groups, and I've anticipated calculations. So I might say, did anyone see 4 plus 4 plus 1? Ah, Helen, you saw 4 plus 4 plus 1. Could you explain where? We'd have the picture up and we can have Helen explaining. And then I might ask, well, did anybody see 8 plus 1 in that picture? Oh, Andy, you saw 8 plus 1. Can you explain where that is? And Andy explains. And I've deliberately chosen 4 plus 4 plus 1 and 8 plus 1 because there's something I want them to notice. So what do you now notice about those 2 calculations? Where is the 4 plus 4 plus 1 in the 8 plus 1? What's the connection that we're seeing there? Right, what about this calculation? So by that anticipating, what you can do is you can sequence and build the learning, but the children are doing all the explaining. They're identifying, yeah, I wrote down 4 plus 4 plus 1. They're explaining where that is, and then they're making connections. But then I can send them off independently again and say, right, well, I arranged 9 objects, but could you arrange, I've put Y, it could be anything you like. Can you arrange 12, 24, whatever, so that you can see different numbers or calculations? And depending on what you've been looking at, the age of the children, you might want them to be arranging things so that you can see multiplications and divisions, or you might want to be able to see additions. And the idea is they would go and explore with some objects first and then draw their arrangement. So we're getting that manipulable in there, and those objects could be Lego bricks, it could be pasta pieces, it could be whatever they like. And then they write down their calculations that they can see and they send them. And then we go back into groups again. And now we're using what they've sent to you to support the next bit of reasoning and thinking. So we might be now talking about Helen wrote these calculations. Can you arrange your objects how you think she did? Does anyone have a question for Helen about her arrangement? Which of her calculations were most useful? Which made you wonder? So now we've got more discussion coming from the children. So what we've looked at there is this change that we've suggested, that there are increasing opportunities to both reason and share thinking. And we're looking for learners to do those things, notice and wonder, create their own examples, have opportunities in small groups supported by the teacher to talk about their thinking and to listen to others and to discuss other children's thinking, challenge thinking, agree and disagree, and that we support mathematical talk through things like sentence starters. And there are two simple approaches that we're suggesting, that you work on rather than work through the maths, by adding in questions that push the reasoning, even when you're doing things like practicing calculations, and that we have more opportunities to explore and share visual representations.